All right, just some brief announcements. We do have a few helpful resources out in Portal on previous training sessions and resources, as well as dates and topics for future sessions related to the SAS Viya transition. So I'll go ahead and post those in the chat here shortly. And some administrative announcements, the usual. So this meeting is being recorded and we advise that you stay muted to minimize interruptions and use the Zoom chat to ask any questions related to this topic. And also all meeting materials will be made available in the CCSQ DNA portal. And with that being said, I'll go ahead and stop screen sharing and hand it over to Dan, our speaker.
All right, thank you. I have just posted the link to my notebook. If anyone wants to follow along, they can feel free to do so. All right. Let me move a few of these things to the side so I can actually see what I'm presenting. And we're good. So I'll be honest. I guess, first of all, thank you for coming to this presentation. My name is Dan Anderson. I've been with the QDAS project for now about 18 months. I have a background in data science, definitely a lot of SAS, a little bit of Python and R, and now obviously making that transition and learning a lot more about the Python and R work, as well as the Spark and Databricks environments. So today's presentation is really going to be focusing on some of the nitty-gritty of under the hood of Spark. And the reason I'm presenting this information is because there's a lot of stuff in the Spark UI that we have access to and can really inform us of what are our current problems in a particular script. Say, I'm sure we've all had those moments where we run something, seems like it's running fine, all of a sudden it gets to one step and it takes like 7 hours, and we have no clue what's going on during that time. Well, there are the Spark UI is actually tracking what's happening during that time. You just have to know how to read it and what the key takeaways are from that user interface. So we're going to focus on that today. So my primary goal for all of you is to be able to identify and resolve some common causes of prolonged processing and failures, as well as gain greater familiarity with Spark under the hood, familiarity with Spark UI, and some additional insights for code optimization. My introduction, we're going to start by, we're going to start, we're going to talk about introduction, some introducing some concepts. I don't know why it is, but I always seem to lean into the more theoretical concepts. But there are a few of these things that we do need to know, specifically talking about Spark partitions. We'll quickly review lazy evaluation aspects, which came from, were introduced in the 3rd and 5th office hour. We'll talk about types of Spark operators, and then Spark execution plans, which was also covered in the 5th office hour. And then we'll go into the Spark UI, and I've got a couple examples that we can use some Spark UI tracing and try to understand what's going on underneath the hood here. A couple caveats I like to start with, just so we're all on the same page. Since we're focusing entirely on this entire conversation on the Spark UI, we're not going to discuss anything that's not distributed. So any like non-distributed work that you sometimes do on the driver nodes, or with like Panda, like base Panda or base R, we're not going to, none of this is going to be relevant to that specifically. Also, we'll need to acknowledge that Databricks or Apache Spark may change some of the default behaviors in the future of this present, after this presentation. One example of that is something we'll talk about later, which is adaptive query execution, which was created, I think 6 years ago. And then it was like the default was that it was turned off until about 2 years ago. And now the default is that we always use adaptive query execution. But if you're used to something different, those are things that we need to, they just do that to us. And so we keep an eye on it. Likewise, there's this concept of liquid clusters, which are coming in the near future, and may also have some influence on troubleshooting. Memory management and caching are not really discussed here. I'm not going to dive into it because that becomes an art of its own. But it's it's worth acknowledging that there's a component to it, but we won't discuss that at this time. All right, so first concept and first thing that we really need to understand when it comes to Databricks is this idea of just knowing your tools, knowing the libraries that you're using, knowing the compute resources that you're using, know what's actually at your disposal. And in the past, we never really had to think about it much when we were on SAS because it was what it was. And we didn't have anything beyond that, right? So like there weren't really alternatives. We could chop something up a bit smaller, but there's a lot more that we can do with Spark and with Databricks. So it's important that we understand what our compute resources are and our libraries. Another main reason for knowing this is that we're dealing with clusters now, right? And so you've got a driver node and you've got worker nodes. And sometimes you may think that your process is running really slow and you need to somehow increase the memory or something like that. But then when we find out troubleshooting wise that it's actually, increasing, like you may not even be using all of the worker nodes. And it's actually a more foundational issue with the way some of the data is distributed or the code is written. So, all right, let's talk about our compute resources. Here, I've taken a snapshot of the CDR PDA QDAS compute cluster. Each of you will have something similar for your org. You've got the configurations here. Along the top, you've got your notebook. At the time, it was just my notebook that I was working with that was on some libraries, an event log, and then the Spark UI that we're really going to lean into later on today. Note that here, some of the key components we'll talk about like the Databricks runtime version is currently like 14.3 LTS, which is long-term support. And that means also Apache Spark 3.5. And also to note that is running Scala 2.12 underneath it. Our worker, we have a driver node that has 32 gigabytes of memory and 8 cores. And then our worker nodes, each of them are 16 gigabytes of memory with 4 cores. And we can have expanding from 1 minimum worker up to 30 workers running at the same time. And we've got auto scaling enabled. So the Databricks will be able to sense when and the Spark UI will monitor how many tasks you have going and all of your different nodes. And we'll say, okay, well, you're maxing out, but you have a lot more tasks that need to still be done. So we're going to spin up a couple more worker nodes. So that way you can complete the task faster. It also works the opposite direction, where it will recognize that you're not using all the worker nodes, and so it will start to spin them down for you. Our libraries, you'll see we've got 2 custom libraries that are installed on all of yours. They're Spark. They're both distributed Spark libraries that are one that's intended for working with Excel files, and another that's intended for working with SAS7 BDAT files. So again, as a summary, in your resources, you've got the driver node, which is just one. You got your worker nodes, which starts as 1, but can go up to 30 with auto scaling. Databricks runtime version is 14.3. I've got the links here to the announcements. Whenever these are put out, they'll usually say what the big changes are. Spark versions 3.5. As I'm sure we've keep mentioning, Spark itself is an open source product by Apache Software Foundation, but is used by Databricks in their environment, and then they make modifications to Spark. But most of the Spark documentation, most of the stuff that you're going to notice with performance work with Spark is really going to be done by Apache Spark, the Apache Software Foundation in Spark. But you'll see here, this is the release notes from Apache Spark directly, and then this is what Databricks announced when they were integrating it. Our clusters all have, on the Spark 3.5, and with the Databricks runtime version, we've got Python version 3.10, 0.12, and R 4.3.1. Details are within the hyperlinks. The libraries, there's a number of libraries that are come pre-installed on Python for Python as well as for R. We have this custom Spark Excel and the custom Spark SAS7 BDAT. These are document sources, links to the documentation for those. Also, if it's in the CRAN repository, you can install directly into your R cluster. And if it's in PyPy, the Python package index, you can install with a pip install to your cluster directly for Python. A couple terms that we're going to talk about is the concept of Spark partitions. So I don't know if you've thought about it. We do the math on these. We're like, oh, great. You've got, 30 at 16 gigabytes. So that's, what is that, like almost 500 gigabytes of memory that you can be using. But sometimes data sets that come in are like terabytes. So how is it that we're still processing terabyte sized data on something that's actually much smaller? And the reason we're able to do that is through Spark partitions. What it does is it takes your full data set and it breaks it up into smaller chunks. And those smaller chunks of data are what are referenced within when it's run, when a task is sent off to a worker node. The worker node will look at the task and the corresponding piece of data and bring that in and to process it. So if you think about it, your worker node doesn't have to fit that much of the data. It has to be able to fit a partition of the data. And then there's a little bit of overhead with communication as well, but that's ultimately how it is that we're able to process large data in a Spark environment. I do want to call out that both Hive and Spark are Apache products, and both have partition attributes, and although they both really refer to like organized subsets of a superset of data, their usage, definitions, and purposes are very different. So don't try to like make some comparison there. These are very distinct. And so throughout this conversation, all we're really talking about are Spark partitions. One thing that's worth noting is also that when you're trying to optimize code, we're not going to go too much into that, but one of the big things that they do is actually just adjust the number and size of your Spark partitions. And that way, because if you have too many partitions that really don't have much data in it, then that's too much IO for no payoff. And then if a partition is too large, then it won't fit onto the worker nodes, and that could be a problem. So there's for the most part, the defaults are sufficient, and Spark has a lot of optimizations built into its process, so you don't have to think about it. But it is something that if you really want to tinker with it, you can probably find, some gains in that. We're going to talk about lazy evaluation. So we brought this up in office hour number 5 when we were talking about when we first started talking about PySpark and data frames. But ultimately, all you really need to remember about lazy evaluation is that it's the process that is used by Databricks and Spark specifically to process and track your code. So, for example, Spark operations are categorized as either a transformation operation or an action operation. Transformations are logged, but not executed until an action is actually submitted. So you'll see within your code, frequently one cell will have run in like 2 seconds, and then the next is like taking 5 hours. And really, odds are that what happened in that 2-second cell was just a logging transformation that it just need to track. Okay, this is something that we'll keep an eye on once we get to the action, but we're not actually going to do anything until there's an action. As a general classifier, so Spark, I'm trying to keep this as accessible as possible. One of the problems that we will see as we dive into this a bit deeper is that for all the brilliance that they have, Spark was created not by analysts, but by computer people. And to that end, at the end of the day, a lot of it's in Java, and a lot of it is still in Scala. We use the PySpark APIs and R APIs so that we can make something, that works in a language we're familiar with. But at the end of the day, they are using something a little bit different than what we have. Everything kind of, all of our functions that we know in PySpark actually work into some sort of routine of processes that are built out for an RDD. If you haven't heard of that before, it's a resilient distributed data. It's effectively, if you think about each of your columns as a single array, it's a way of managing those. So a column as an array can be an RDD. And that's where all of our actual processing occurs at that level. I bring that up now because a complete list of action operations would honestly require me to dive into the Scala code and identify all the specific RDDs functions there. And so it just doesn't exist. They tell you how you could do it, but it doesn't really exist. These are some common action operations, but these aren't, all of the action operators. I also made that detour because you'll see references to the RDD when we start talking about the Spark UI. So I don't want you to be blindsided by it, but we're going to try to we're going to focus on a takeaway message that's kind of at that interface between kind of knowing enough, but not drowning in the computer science of it all. So action operators can generally be identified when you talk about like requiring data output to a file or to display, or if there's like a fundamental alteration to the rows in a data frame. So, when you're looking at an account, creating a count is an aggregation event. And at the end of the day, you end up with a single row that tells you your count. Or, if you did a group by a number of rows. And so there had to be a calculation in order to return that, and an aggregation event that basically fundamentally changed what your output data frame was going to look like. And those are typically what your action operators are going to be. You can see like a describe or distinct or head or show or summary. All these basically have the same concept in that they're going to put something out to your display, or write something to a table location so that it needs to actually have processed the data. Like you can't just submit the log of transactions or of transformations. Transformation operations are pretty much any other data operation. Feels a little like an easy way out to say it that way, but aside from a few code snippets that you can use for like adjusting settings or configurations, most of what you do are actually transformations. We have two types of transformations we're going to discuss. They're called a narrow transformation or a wide transformation. The idea is that a narrow transformation can be performed using a single partition of data. And usually a general rule is like it comes in as one data set, and usually it's going to have the same number of rows and same type of data set in the next in the output. It's like a one-to-one mapping of your inputs to outputs. Whereas your wide transformations require information from other partitions. So if you imagine these are partitions, like subsets of your data set, we can run a select, or even some filterings or a union based on what is in here. We can pretty much create an output that can be then appended, but it doesn't need to know the output from partition 2 for partition 1 to be complete. And wide transformations are things where we do like joins or a group by, or sorting, or looking at distinct counts. The content of one is going to affect and need to be potentially like the output, the summary data needs to be aggregated as well and calculated again with the output from partition 2. And they all kind of create this big mess. Wide transformations are going to be much more intensive. They're going to take longer to run. And, we accept that they need to be done, but it is, probably a better practice to look at, well, do I need to do this wide transformation on this size of data? Why don't I do all the narrow transformations first and reduce things? Because a filter is a narrow transformation, right? So filter things first and then do my wide transformation. Narrow transformations are much easier to distribute because you can send it off to one worker node and it doesn't need to communicate between the different worker nodes. Whereas the wide transformations would have to have the nodes communicating with each other and back up to the driver. Some common transformation operators include like a select statement, a filter, or a union, and those are all narrows. Wide ones would be a distinct, a group by, a sort. A lot of those are wide. So these are the main, this is really touches on all the concepts that we need to be aware of as we're thinking about how our Spark execution or our Spark program is being executed. I will just, in topic 5 of the office hours, we also talked about execution plans. This is directly cut out of that previous execution plan one. And actually, while I'm thinking about it, let me run all this stuff and I'll come back to it. Okay. Here, there's a link to the office hour as well as the in there, you'll see one version of you'll have the video and one version of the notebook. We later reworked the notebook a little bit, and there's an alternate notebook you can look at. here in this execution plan, it doesn't really matter too much, but what's happening is we're reading in a data frame of, I think it was like maybe 12 rows or 8 rows of data. And then we were selecting just 2 of those rows, and then we were filtering 1 of those rows and then displaying the output. So the Spark transformation, there are stages to the execution event. So you submit the action, such as, like, in this case, it's the display. And that indicates that the data transformation has to occur now. I will focus primarily on these first 3 columns. The 4th is example content. Again, I recommend feel free to go back to the office hour for more input on it. But when you're creating these execution plans, Spark creates a parsed logical plan that basically is the initial blueprint. And then you've got an analyzed logical plan that verifies that the column names and types support the types of transformations you're trying to do. And then I'll try to optimize it and look at, is the ordering proper in this? And then it will create a formalized physical plan. And that's going to detail how the operations are carried out. And and then the final step, and we really didn't talk about it before, was the task execution. So what happens in the task execution is we've taken this physical plan and we break it down into pieces. And the pieces are broken down by, and if you consider it a hierarchy, you have jobs, followed by stages, and then tasks. So you can have multiple jobs in a single execution related to a single action, and then multiple stages within a job, and then multiple tasks within the stages. And the tasks are what are submitted to the worker nodes specifically. So, and worker nodes can sometimes be called an executor when talking about processing. We'll see the term executor in the future. And then these results are typically returned back to the driver node, and we get the data that we see. So that's a lot of background to bring us up to really where we wanted us to be, the Spark UI. I have cheated here, and I will note that I am no longer on this particular one. I'm actually using what's called a minimum compute cluster. It was a custom cluster I created for purpose of this presentation. And the main reason for that, I'll show you, is just that I wanted to have one that was a smaller driver node and smaller worker nodes, as well as a smaller number of maximum workers, so we can kind of stress test it a bit better. And then we can, but it does, everything else is the same as before. What we can see here, I will show you. So we talk about the Spark UI. Here's a snapshot of what the Spark UI can have. So in this particular case, if I were to go to like my general compute cluster, everybody's jobs will have been submitted there, which is fine because I can find it through my notebook. But I just wanted to show like kind of a cleaner log for purposes of this presentation, which is why I have like a unique cluster for it. So we'll go into this. There's a jobs tab, a stages tab, storage, environments, executors, SQL data frame. The jobs tab, let's just take a quick glance in here into Spark UI. There shouldn't be anything. Oh, yeah, I did a run all. So we've seen now that it's run 5 jobs. 1 job is still active. We see, when this was up, how long it's been up for. You can see an event timeline about the cluster itself. So there was the driver node was added at this this time, and then the executor 0, which is the worker node, was added. And then you'll see here some of the work that's actually been performed, these jobs. You can see for each of these, there's going to be a corresponding stage. So if we look at the number of stages, for example, we can see, we've run 5 jobs, but we have, that's not what I want to do. We've looked over 5 jobs. One of, 2 of them are, 2 tasks are still running there. But we've actually, so far, we've done 6 stages. And so there's not necessarily a one-to-one. You can have multiple stages within a specific job. I wasn't able to find a very clear definition of when one job starts and another ends. I know that stages within a job, if you end up having to do like a wide or a shuffle or something, like a wide transformation or like subsequent wide transformations, each of those will spawn into like a second stage. So that's, usually it's one stage per job, unless it's something that requires a lot of shuffling. So kind of like a wide transformation or lots of data. Each stage can then also have, we'll go into talking about the tasks that are related to each of these. And there is a component here called storage. Storage here actually isn't about disk storage. It's more about how much data has been run, like IO, that's been processed and potentially cached in your workers. So we're not talking about, we're not actually talking about disk space. We're talking about memory that may have been set, like how much memory has come into it and been processed. And then also how much has been cached. If you cache something in your memory, then you're taking away from the available memory for processing. So just recognize that there are times to want to cache, but it's not always the case. And that's why I said earlier, that's really more of a secondary topic of its own. Environment, it really is just all the environment variables. It's nothing particularly exciting. And then your executors. Executors are going to be talking about your worker nodes. So here it's showing 2 active, 3 total executors. So I've got my driver executor, executor ID 0 and then 1, and these are the worker nodes. So at one point I used 2 worker nodes. You can see one of them is now listed as dead. So that auto scaling caused it to just no longer be necessary. And you track your time that was added and removed and the amount of data that was processed here within each of these. There's other sources for troubleshooting that will be a little more informative. Laura, I think, are you talking about Courtney's question here?
I am, yep, but we're just gonna read it out loud.
Yeah. So Courtney, you ask a good question. It's like, is there a reason why some stages are skipped, and should that be a concern? So there's a reason why some of these stages are skipped. In fact, we'll have one in the example here, but ultimately it comes down to this AQE, adaptive query what is it? Evaluation or something like that. It's an optimizer that's utilized by Spark. And what it does is it looks at what data and what content you still have available, and what is something necessary to be done the way it was originally planned. And so it will adjust it. And when it makes those adjustments, frequently an entire stage can be disregarded. The only time I would be, so if it says skipped, I wouldn't be worried about it. If it says failed, that's a completely different issue. All right, so we've talked about executors. SQL data frame is something else I would like to talk about, because this is probably the only thing that's going to make the most sense to you, because it will look somewhat familiar. So each query, I think, underlying all of our work, whether we write it in PySpark or something else, it's going to be related to, likely going to have like some correlation to a SQL or some sort of data frame path, execution path, or language. And so these get an ID and they're tracked. And so we can look at like, what is the actual path and how does something actually happen? And that will help us read and understand the tasks and what exactly we're doing. All right, having said that, I will go back to jobs. All right. So we're going to talk about two examples here. One is, both these are very simple wide transformations. It's just going to be, we're going to import the data, and then we're going to run a group by an account. So your count is going to be your action item. Group by here is a wide transformation. And then, of course, we're also doing a display, which is kind of an action item as well. What I am using, I'm running low on time. So I've put here, we have created a Hive schema, or in the Catalog Explorer, that everyone can access, called CDR PSA Community. And it's going to be the source of all of our, like most of our data, like example data that we utilize. And so I have in here a link to the announcement that was provided, some documentation to each of the contents of those tables and what they're ideally used for. And one of them that I am using is going to be this large New York City moving vehicle or motor vehicle crash data, which is from New York City's open data. Just so you understand, we've got, so we've got CDR PSA Community as the schema that everyone should have access to. The file, the table itself is this. Likewise, there's a workbench that you should be able to access. But more importantly, so this is just demo data that's open source. It's got 2.1 million rows, and a better listing of the data dictionary in the PDF file at the top here. What I'm going to use that for is, I'm just going to, again, run this group by and count. So we can see I've run this. I ran it 13 minutes ago. It took 25 seconds to run. And here I've got, which is, I mean, honestly, I've got like a relatively small cluster, and it ran through, what was that? 2.1 million records, and did the aggregation on it in 25 seconds. I'm sure we've seen similar things with our claims data as well. So if you look in here on your log, especially while you've got your cluster still active, you can click down on the Spark jobs and you can see that this job itself, this action that we've submitted was defined as 2 jobs. And the first job, job 0, had 1 stage that succeeded successfully, called stage 0. Job 1 had 2 stages defined, a stage 1 and a stage 2. You'll see that one of them was actually skipped. So stage 1 was determined to be able to be skipped. And then stage 2 was successful. So really we ran 2 stages. If you click on the job data from here, it will show you the job 0 data from the Spark UI, as well as the associated SQL query that was related to it. And it will show you the timeline. So again, here we have the driver added, and then just one executor 0 was added. And then for this, there was later on executor 1 was added. So our second worker was brought online at this time. And then executor 0 was decommissioned shortly after. There's a visualization that calls it shuffle map for this first job. And you can look at, this is the stage, so stage 0. And if you select stage 0, it will also tell you here how many tasks were a part of that stage. So it just had 1 task and it ran successfully. But if you click here, the 1 task, you can see more details about it. So this is why I mentioned RDDs, because it's talking about RDD type functions, map partitions, scanning of the file. What you can see here, though, is you've got 1 executor that was actually run for this whole thing, this entire process, this particular job, and this stage, the stages associated with it, were all completed with 1 executor. So it was basically written out into a single task. The single task was submitted to the single executor. If there had been multiple tasks, you would have seen a second task added in this. This right here, this 0 is a reference to the actions within the executors of the worker nodes. I generally like to point out, so this is we talked about the associated SQL query. The associated SQL query is here. And this is what shows you the plan as it occurred. So you can expand on this and it will show you a lot of extra information. If you look at details, here's the physical plan, how the initial plan was put out. So a quick read here, just kind of like an interpretation for you is, here we're reading in and loading the data from the Spark catalog. And then there's the aggregation event. Then you have to shuffle those aggregations because they're usually chopped up as different tasks. And then a second aggregation occurs up here, like an aggregation of the aggregates. And then you've got the output put out here. When it went through an AQE stage, you can kind of see, so from here, it talks about how many, where's the partition information in here? Data rows. Here we go. So the rows that are expected to be scanned are 2.1 million. File sizes to be read, like all this extra content is in here. But it also says, okay, we're going to assign this all to just 1 task because the total, like the largest file size and the total size of the file is just 67 megabytes. So it doesn't exceed the size of what a standard partition would, so it can all fit into one partition. We can go further in, and you would see additional content here. And then the AQE here, you see this is where it decided it can be coalesced into one partition and stay within that partition size of 390 bits. And then your column gets output. It tells you the estimated number of rows and batches that need to be put out. And then you get your results. So that's the SQL. The associated SQL probably tells you more information than trying to go through and understand all the individual tasks within a stage. But it is good to note that this is an option. I will quickly, so just to show you on job one, the one stage that was skipped. If you try to open that stage, it tells you there's no details because it didn't have to do it. So yeah, since it was just skipped. I want to call out, so in this particular one, we noticed that there was only one executor used. It was really just one task. Well, let me get into stage two and make sure that stage two didn't have additional tasks. No, it's also one task and one executor. So, and then we know that there were 3 stages, one that was skipped, and this was actually 2 jobs to run this one stage. I know we're getting late, and so I just want to quickly go over the example with the New York City taxi data. This is also available on our cluster. This is one of the ones that Databricks provides as a sample data set. Here I'm reading in these CSV files for 2009 and 2010. For 29, you can see this is kind of what the structure looks like, and it's just ride data. We're going to look at a grouping by the payment method, payment type, and we do that here. Here we see that it actually took 3 jobs, and again there was one that had an entirely skipped stage 7 here. And you can dive into each of these to figure out more. What I will point out, so you notice in stage 5, there were 10, it was one stage, but there were 10 tasks. The 10 tasks that were here were because there were actually, try to pull it up right here. You'll see there were 10 files that were being read. And so it was running it in parallel. Each task was just running that one read. So that's stage 5. And you can see here, you've still got them all running on a single executor. Probably because a second one hadn't come on in time. But you can see each task happens at once. And remember, we were talking about that each of our worker nodes has 2 cores. So each worker node is considered an executor, but the number of cores will determine how many tasks you can take on. So it could take 2 tasks at a time. So once one was done, a new one came in until you've completed all 10 tasks. The other part I will show here, finally at stage 8, it was just one, oh wait. Yeah, 10 tasks for that. Then stage 6 comes in and ends up processing a large amount of data. So here they've determined 7 tasks and you'll see 1, 2, 3, 4, 5, 6. And the seventh one, the second executor finally came on. And so I was able to start to submit to that one. All right, I see your question and I want to get to it. So I'm probably just going to have to leave it at this point. What I will do though is, this is kind of a complicated thing that requires a little, depends on how deep you want to get into it. But I've provided a lot of content for additional resources specifically because of that. A couple of videos from Databricks for Professionals talking about the Spark Web UI, Advanced Spark, some Apache Spark core stuff. All of these are bits and pieces that I've pulled from throughout this whole period. What we do want to most look at, and I'll show you one thing here, is when we have all these different tasks going on, we kind of want to look at oops. We want to look at these and we want to see how many, okay, where is this at? I've lost it for now, but you want to be able to look at and say, okay, well, most of my stuff is taking, like, you can show up here, it tells you the compute time was 2.5 minutes, all right? This one is shorter. This one took 1.4 minutes. And you can look at the executor, the task details, and identify like all the different metrics of this. But ultimately, you want to make sure that they're all running about the same amount of time. You also want to make sure that you're using the same, like the maximum number of cores. So if, like I said in the past, perhaps I'm running something, it's taking a long time to run. But, you know, it wasn't until this point that I was even using my second executor or second worker node. So if you don't have enough tasks to occupy all the cores, then an issue might be the size of the data or the type of process, the duration, whether it's a wide transformation, the amount of communication that's required to complete the actual the entire action. And so those are what I really wanted you to come down and understand, that everything is going to get broken down into individual tasks, that the number of tasks that can be processed at a single time are set by the number of cores and the number of worker nodes you have. And beyond that, you'll want to dive in. And if you see one particular executor that's, or one particular task is taking a really long time, then that's kind of your target. Where are your bottlenecks? And that's what you can gain from the Spark UI, is identifying, you know, what exactly was the task and what was the problem with the data. If there's a failure, you don't see it because we don't have any, but if there are failures, you'll usually get like a failure log or a description of what the failure was. You know, should there be a failure. Sorry, I know I can be talkative, and I know this is a lot to go over. I do encourage you to not be too intimidated, and look at the additional material, and just play around with your own Spark UI for your jobs as you've run them, particularly the ones that take 30, 40 minutes or anything that's taking more than 5 minutes. Try to see if there's, you know, what's in there that you can perhaps, you know, target next. And having said that, I will try to end this a little bit earlier. I am looking at this question here. What of these concepts or components would you consider most analogous to a SAS program log in terms of capturing execution details, warnings, errors, and other operational messages? I don't know if there really is an analogous component directly, because even the errors, as you've seen in your notebooks that will come back to you, the errors are really more of the specific Java function that failed, or the Scala function that failed, and kind of gives you this roundabout discussion there. Some of the DAGs, if there's an error, sometimes it will say like, oh, it was a character representation issue, or it can give you a decent description if a task has failed. But even that, I wouldn't consider quite like a Spark or like SAS, and I think that's something we are going to run into. And SAS was very good. SAS really integrated computation and data work into one environment. This one still, Spark is a compute tool. And so it's going to focus on kind of the compute components of it, and really like a data, the specifics about the data itself may not really come out in Spark directly, and may require a bit more troubleshooting and diving. But if you come across something that you'd like some help with, please reach out to us. We are working on developing additional training material for everybody. And I would just say that. Should we be able to see DAG visualizations tab? I don't see it under jobs on my end.
Hey, Dan, while you're
Yes.
looking into that, do you mind if I put out the survey? That way people
No,
get enough
absolutely.
time.
Go ahead.
All right, sounds good. So I'm just going to put out a survey right now. This helps us know what sort of topics you want to see next and what you thought of today's topic as well. So you should see that on your screen now.
Should we be able to see the DAG visualization tab under the jobs on my end? I'm sorry, Courtney, you're talking about this DAG visualization here? Like when you've come into a single job? Like the details for a specific job?
Should we be able to see that on our end? I tried to follow along to figure out where those visualizations pop up, and I couldn't find them.
It should be there. It would be under the you have to select, so like if you have a specific job, and then under the description, I just click on the link here.
Oh, okay.
And if there is a DAG associated with it, like it will show the event timeline as well as the DAG. And
Okay.
here's that stage 7 that actually got skipped, and stage 8. And then when you click on stage 8 or one of the stages, it will take you down and drill you down into the details for that stage and the content in there.
Okay, thank you.
All right. Thank you very much for everyone's patience and time. We did call this I think we did call this kind of like a part 1, because I know there's more to discuss. Not sure when that's going to come out yet though. So thank you for everything. Appreciate it.
Thank you.